Hello, my name is Miguel Solis, and I will be covering the 3D printer. I will go over some of its history and be answering questions such as why? Why do we need 3D printers? Why should we continue to invest in them? And why do so many people think they are the future of manufacturing? One of the advantages that 3D printers have over traditional manufacturing is that they can create complex geometric shapes. Traditional manufacturing makes simple shapes due to the limited flexibility of the manufacturing processes. Processes such as extruding or casting or slush casting, these are confined to molds and shapes that are already predetermined. With 3D printing, you can constantly change your shape. Prototypers are constantly changing their design due to unforeseen obstacles that they didn't think of before. So this is a special use that the 3D printers have over the traditional manufacturing. Related to that point, we can say that the prototypes that the 3D printer creates is already closer to the final stage. This is because prototypers are constantly making prototypes out of scraps, and they don't really look like the final product. But with 3D printing, using CAD software, we can create exactly what we want in the final product or something that is very similar to it. This is something that 3D printers have over traditional manufacturing, because if you want to order a very specific part or design a part that's very specific, it will cost more in traditional manufacturing because you are not mass producing this part. The reason companies can afford certain parts at such a cheaper price is because they mass produce them in high quantities. So when ordering one part, it may not come out as cheap as you would expect, as cheap as the companies would like. So in this case, the 3D printers have an advantage over traditional manufacturing. Another advantage that 3D printers have is that they can deliver a unit on demand with short time. When you order a part from a manufacturing facility, this part is often shipped from places like China, Indonesia, Mexico, or India. This comes with often multiple days to weeks of shipping time and increased price due to the shipping cost. With 3D printers, you can print whatever you want and have it built within two days, because if it's a large part, if it's a small part, it can be 3 hours, 4 hours, 1 hour, 6 hours. So, and there's no shipping costs. So in this scenario, the 3D printers, again, have this advantage over traditional manufacturing. This also has the potential to reduce labor and cost. It reduces labor because there are no humans anymore controlling the machines that are producing the parts. Now it is all done online through the software, and the printer itself makes the part. And of course, this also reduces cost. And like I mentioned earlier, with the shipping cost, there's no shipping cost anymore because it can be done in your town, in your city, in your home. Not only that, but companies do not have to mass produce and sometimes overproduce their parts anymore. Now they can produce on demand. This is the potential for additive manufacturing machines, in other words, 3D printers. This is the potential they have. Now there will be no more excess, no more waste, which is a material cost as well as a human labor cost. Because other industries have looked at what the 3D printer can do, it now creates a necessity in their industry. For example, Cellink, a Swedish company, has introduced the first standardized commercial bioink in the market, derived from a seaweed material called non-cellulose alginate. The bioink can be used for printing tissue cartilage. This is a prime example of what the 3D printer can do and how diverse it can, the broader range it can cover. It is also used in the meat industry, where lab-grown steak is 3D printed. It is still beef, it is still genetically the cow, but it is just 3D printed and grown in a lab using the cells from the cow. It is also used to make houses now with concrete 3D printers. And their metallic 3D printers also exist, but although they use a different form of 3D printing. Similar to the paper printer, the 3D printer is moving in a direction that is consumer-based. Not all 3D printers, but a subsection of them. There are those that are meant for manufacturing and for businesses, and they're very expensive. But there is a side of 3D printing, a world of 3D printing, that is meant for the consumer. This opens up lots of doors for lots of people. Now the average person can create whatever they want, whenever they want, however they want. They have this ability now, so whatever creation or innovation they have in their mind, it can now come to reality. Imagine if Apple or any other startup you can think of back in the day had a 3D printer. It's a game changer because you can bring your models, your prototypes, whatever's in your head, you can bring it to life now. So as a result of 3D printers, innovation can go up, more inventions can come about, things like this. Here I have the parts listed for a FDM 3D printer, that is a fused deposition modeling 3D printer. This means that the filament is put through a hole that feeds into the nozzle where it gets heated up and printed on the print bed. First, we will start with the Z-axis. The Z-axis uses rotational motion through the stepper motor to drive up or down a lead screw. You can't see it in the picture, but there are lead screws here, and once the stepper motor turns, it spins, the screws spin, and it drives this X-axis rail up or down. And that brings me to the X-axis. It also uses a stepper motor that converts rotational motion into linear motion by controlling a belt that causes the tool head to move along a linear rail. This is more or less the same case for the Y-axis. It also uses the stepper motor, converts rotational motion into linear motion for the bed by moving the belt. And another main component is the nozzle, which is fed with the material cable, and it just heats up. Once it heats up, it is guided by a stepper motor that it guides the filament to extrude it through the nozzle. And the last main component is the print bed, which heats up in order to heat the build plate so that the filament can stick to it adequately enough. How has this technology expanded? Well, for one, we've gotten various different types of 3D printers now. The first 3D printer was a stereolithography one, SLA, which works by dipping a plate into a plastic resin. This plastic resin is hardened by shining a UV light through it. So what they would do is put this plate into the plastic resin and have a computer accurately shine UV light in certain spaces so that the resin can harden on the plate and then print layer by layer essentially. This first 3D printer was created by Hideo Kodama. He created the first ever 3D printer. What followed soon was a method called selective laser sintering, SLS for short. It uses a carbon laser which fuses powders together. Instead of the laser being a UV light, it is now a carbon laser, and instead of the plastic resin, we now have powders, which can be metallic powders usually. This expanded into something called direct metal laser sintering. the only process that can produce full metal parts. This method was patented by Carl Deckert in 1987. Fused deposition modeling 3D printers, which is the one that we showed with the listed components. This type of 3D printer was invented in 1989 by S. Scott Crump. This is where the material cable is fed into the heated nozzle and then printed layer by layer, as we saw in the previous slide. This is how 3D printing has changed. Various different types of 3D printers have now come out, and even in those categories, there are now subcategories, such as in fused deposition modeling 3D printers. There is now a Cartesian version and a Core XY version. And 3D printers continue to evolve as we unlock other materials, which brings me to my next point. The selection of materials has changed drastically. What started out with just plastics now has expanded to concrete, thermoplastics, meat, metal, and even a seaweed-based filament used to mimic organs in the body. This is something that has changed and has given 3D printers more utility in different areas of life, different areas of different fields, different industries. Another thing that has changed drastically is that 3D printers, the price of a 3D printer has gone down significantly. Back then, a home 3D printer would set you back over $10,000, and an industry-grade equipment would cost even more. Now there are Core XY 3D printers for less than $500, such as the Bambu Lab A1 or the Bambu Lab A1 Mini. Even Elegoo released one, Elegoo Centauri Carbon, which is one that is about $300, and it is a Core XY 3D printer. And while price has decreased, quality of print and faster print times continue to exceed expectations. This is due to various reasons, such as more investment, better materials being used, better software integration, better hardware, more people working on these projects, more greater minds, brighter minds, more brighter minds working on these projects. And as a result of this, usability has improved as well. With software integration, such as in the Bambu Lab 3D printers, it is becoming a consumer-friendly product, which is very easy to use, such as the paper printer that we have today. Back then, 3D printers they were called tinker machines, where you would always have to constantly be fixing these machines, constantly tweaking them to make the 3D printers print how you wanted them to print. Now, it is very much out of the package. You put a couple of screws in, you have the software on your laptop, on your phone, on your computer, and you can start printing from the get-go within 2 hours. So this is something that has improved a lot in 3D printing.